right. Before we move on into the, introducing the topic and our esteemed speaker today, I would like to share my screen real quick. It is also a geothermal related topic, which a lot of you have heard about. Give me 1 second. Do I want to continue? Yes, I do. All right. I am assuming that you're all seeing this on your screens. Give me a thumbs up, Ivan. You can see it? Perfect. So the Geo Hackathon is about to start. It's T minus 10 days. What we've done is we've combined geothermal energy, we've combined bootcamp sessions on geophysics and seismics, all the way from the beginning to acquiring and interpreting. We have combined a challenge, a hackathon that will be in the month of November. And most importantly, we've combined people from all over the world that were willing to give their time to this project. What's important is that you all support us, and those that are interested to join, you can scan this QR code. I will actually zoom it in, make it easier for you. Register, share. It's an event that's super important. It's the 3rd edition, and we have plenty of time. You don't have to do the hackathon challenge. You can only go through the bootcamp schedule, but we encourage you to take a stab at it, to try to solve this challenge that we have prepared with the other sections from Europe. I'm going to stop sharing my screen, but please feel free. I will drop in the chat box a link to the hackathon website. Feel free to take a look at it and ask us any questions that you might have about it. So I am going to stop sharing, and then Ivan, you can just a second. Okay. Ivan, you can go ahead and share your screen. Perfect. So I would like to introduce to you our today's topic, the special geothermal talk number 7, making a difference in geothermal energy in Ukraine. Essentially talking about the whole concept of geothermal energy, what has been done, what has not been done, and most importantly, some of the discussions that Ivan and I had were, what are the challenges? What are the things that we need to work on, all of us together to solve? And that will be part of Ivan's talk today. I would like to introduce him. Ivan is a project manager in geothermal and CCUS at UGV. He's an associate professor at the Department of Geoinformatics, Taras Shevchenko National University of Kiev in Ukraine. He holds a bachelor's degree in geophysics, a master's in geology, and a PhD in geophysics from his alma mater, which is great because he's going to help us promote the GeoHackathon as well. He spent over 20 years as a lecturer, initially in the Department of Geophysics and later in the newly created Department of Geoinformatics. In 2022, he joined UGV, leading their decarbonization department and later managing green projects like geothermal, CCUS, and hydrogen. Ivan's research spans to geomechanics, 3D geological modeling, spatial analytics, and geological exploration with fieldwork in Sahara and Southeast Asia. Without further ado, I'm going to pass it to him. And essentially what we will do is pay close attention, have your questions ready, and then we will have a Q&A at the end of the presentation. Thank you very much for being here today, Ivan, and please take it away.
Thank you, Gabriel. Hello, everyone. Hello, colleagues. I am very happy to be here. And it's a very nice opportunity to have a discussion about the geothermal in Ukraine, because the geothermal in Ukraine is quite old and quite new business, and we have a lot of challenges and we have a lot of problems with geothermal, but we very optimistic and want to start the geothermal as a good industry very soon in Ukraine, and let me talk about this, about my view of geothermal today. So the agenda of today's meeting would be, I will start with my brief introduction of my career. Probably it would be interesting to you how the professionals comes to geothermal, because we have not the specific geothermal specialist coming from the university directly, usually in Ukraine at least. And then we will talking about the history and geographical context and geological settings in Ukraine. And then I will go to the framework of some constraints we have in Europe and about the decarbonization constraints as well. And then we will talking how the geothermal could be competitive with the other energies. And then I will go to the economics, because economics first. Economics is very, very important to make a business. And then we will talk about the UGV Transcarpathian case. It's a pilot project. I have like a disclaimer, I cannot show you commercial info about this project, but but only some explanation of this project, how we see this. And then finally, I want to talking about the modeling and about the education. So let me start with my career. It's probably unusual, but maybe would be usual for many of you who is coming to the geothermal. I'm geophysicist and I am working with numerical modeling mostly for most part of my career. So my PhD is inverse problem in geophysics. And I spent many years for petrophysical modeling, working with software developing. I have developed some interpretation tools for petrophysics, for elasticity, for seismic, for thermal parameters, and have applied this for deep seismic surveys and for seismology data. So I have studied the lithosphere from the upper mantle to the of the core. And I spent some time for near surface geophysics and for some environmental projects in different countries, in Spain, in Mauritania, in Laos. And also it was very key point in 2005 when I first time see the Petrel and SLB software. So the 3D modeling became part of my activity for a long time, and the very, very important APG, ABA competitions give me a possibility to see the very different data sets from around the world, and I have the experience of Bayesian analysis in many data sets in Canada, in Australia, in United States, and Spain, and Denmark, and Norway, and so on. And also I have some field trips in Norway, in Greece, in Bulgaria, and Poland to see the sedimentary basins, to see how it deposited, and some interesting features in the tectonic settings. And so it's very, very interesting and very useful for geophysics and also for reservoir engineers, for example. And another part of my activities is the hydrothermal deposits like gold and uranium, and also I have some training for International Agency of Atomic Energy in Buenos Aires, where I have a very good workshop with organized by mostly by USGS. And there I have many things got for data mining and for new approaches for related to the artificial intelligence and about geostatistics, geospatial analysis, and so on. And this is part of my career as well. And now I am trying to combine all of this, my skills and knowledge to the geothermal, because the geothermal is very complex and require a lot of knowledge and a lot of things we need to analyze. So that is why we need such wide experience. So let's me go to the history and geographical context. This is a heat map of Ukraine at depth of 6 kilometers. So as you see, there are very different colors because we have very cold areas and very hot areas in Ukraine, and we have a long story of the research in Ukraine for hydrothermal. First has been done in 70s, mostly for Transcarpathian region, and then we have the research in also in the south of Ukraine, and the first geothermal station was built here in the my homeland in Crimea, and in total was 9 stations with about 11 megawatt in total capacity. And later we have just 3 stations still operating, and one of them is in occupied area. And later in 2010s, there are many projects was developed like a conception, like a pre-feasibility study for oil and gas well repurposing, mostly concentrated in this region. Is Dnepr-Donetsk basin is the main petroleum region of Ukraine, and a lot of these projects we are trying to reconsider, redesign, and probably will try to work with these projects. And now we are trying to start the first pilot project back to Transcarpathia area because it's the most perspective, is the best heat flow. So we are going to go there. So in geological settings, we have the very cold Precambrian shield in the central part of Ukraine. You see this is blue, and this Paleozoic rift is Dnepr-Donetsk basin. Is a lot of wells here, more than 2,000 wells for gas and oil existing here. Some of them is abandoned and can be repurposed. And also here is a bright spot, is a folded called Donbas Basin, also very perspective for the geothermal. And here is the Carpathian Mountains, and here is this Transcarpathian region, is Pannonian Basin here. And here we have a Volyn Basin, is also called because it's Paleozoic passive margin. And here is a part of the Dobruja. And here is my Crimea Mountains. It's very good, and I guess it would be good place for geothermal projects in future when the Crimea back to Ukraine. Let me go ahead with some frameworks we have, because when we are starting for consideration of geothermal energy in UGV, we are trying to understand what the perspective of geothermal and what the demands, because first of all, we need to understand what the demands of energy in Europe and Ukraine. And because it was started right before the February of 2022, there are a lot of dramatic changes in our analysis during the last two years. But we have right now, we have the lack of the Russian gas supply to Europe. It's 130 BCM of gas supply. And what is the substitute for this gas consumption? There are a lot of options for Europe, and one of these options is the heat and geothermal. It probably would be quite good. So the trend for geothermal in the world and the Europe is for installed electricity capacity is quite similar. So we don't see some dramatic growth of this capacity in Europe, but we hope to see these changes very, very soon. For us, as for gas company, we are upstream gas company, UGV, we have a lot of obligations connected to the decarbonization. And when we are talking about the geothermal, we need to consider about the greenhouse gases emission. So we have three scopes. We have the scope one is the internal gas consumption. So we need to reduce our gas emission, direct emissions. It's one part of our decarbonization roadmap. And the second one is scope two. We need to substitute the dirty energy with the clean energy. So it's good chance to have the geothermal energy despite of the gas energy station, for example. So this is geothermal place in this roadmap. And the third scope is our responsibility for the gas we are selling to the customers, and to have to reduce this indirect emission, we need to have the carbon capture and storage projects. So this is why we are looking for the European frameworks, for European legislations, and we understand that we have, when we are planning our projects, we thinking about the future of Ukraine in Europe, because we are candidate status. So when we are designing project for at least 20 years, so we understand that project will start in Ukraine, but will be finished in European Union, I guess. So in this point, we have a very important thing connected to Net Zero Act. Net Zero Act is a game changer for European energy, I think, would be. And the geothermal is also here for heat pumps, and geothermal energy is one of the priorities we have. And the second important things, when we are talking about the economy of geothermal projects, we need to understand that if we are substituting the clean energy, substituting the fossil fuels by the clean energy, we can pretend for the carbon carbon prices for the carbon emissions, permissions. So it's like a quota trading, and prices for this carbon grows very quickly. And we have right now, we have a price about the 100 euros per ton. It's a quite good price, because the previous forecast show us that would be about 30 in 2023. So now we have about 100, and probably this price would be higher in future. So it's good point for us, because we need to include this quota price into our economy. For UGV, we part of the Naftogaz Energy company. We have the only one target for net zero for scope 1 and 2 in 2040 to be climate neutral, but we don't have the such goals for scope 3, but I guess it would be developed by the CCS project. So we have several directions we are working for. This is a synthetic methane, methanol, biomethanol, all application we have connected to Sabatier reaction. Geothermal energy is the second priority, the hydrogen energy is the third, and the CO2 sequestration. And also we thinking about the responsible sourcing, about the extraction of some byproducts. For example, from the geothermal brines, we have some microelements. Some of these microelements in the list of the critical raw materials. So it's quite interesting branch of our activity in the future. So let's go to the understanding why the geothermal is not still not developed in Ukraine. So if we see for the energy balance of Ukraine in 2021, before the intensive war in 2022, we have a big production of energy distributed in half by nuclear, and the other we have the fossil fuels. And here is we have the renewables and hydro energy. For geothermal is sub-zero here. We have estimated potential. This is estimation of Institute of Renewable Energy in Ukraine. So we have a good potential in the west. We have a good potential in the east, northeast, and good potential on south, but we still have not any electricity production from the geothermal yet. And another question about the heat. Heat production is also here, and we have a good part of the heat consumption up to 21,000 of teracalorium is consumption, whole consumption in Ukraine. So we have a good market for the geothermal, but we need to understand why it's still not working. Let's see for the some attributes of energies and compare these attributes between. So when we are talking about the cost of energy, we have a capital cost, we have a fixed cost, we have a variable cost, and we have the fuel cost. This is estimation of behind energy. I take this image. There are not hydro and biomasses here. So we see that the good price we have for the fossil fuels. This is why the fossil fuels is still dominate. And nuclear power very have a high cost of capexes, but very low cost of the fuel. That is why for existing projects we have the another distribution, because the fossil fuels is have a high price and nuclear have a low price. And in this case, if we have installed capacities, so this is the competition would be win by renewables and by the nuclear and geothermal, but we have not geothermal yet. So we are in this point, we need to make many capexes to build the geothermal first, and then we will have the low cost of energy in future. Another option is also very important, is the speed of capacity variation. So we need to have the very short time for response in energy changes. And in this case, we have a very high time for nuclear. That is why the nuclear is like a constant supply, and we cannot change it very quickly. Sometimes we can use some daily variation for hydro energy, for example. And the main maneuverable capacity is a fossil capacity. That is why it's very important. The wind and the solar is uncontrolled. It's weather dependent, and we cannot use these two sources without the energy storage capacity. So we need the energy storage to make these two sources from uncontrolled to controlled. So that is why geothermal has many advantages in this case. So we have a good time of reaction. And another very good point for geothermal is the capacity factor, because if we are talking about the nominal capacity and the real energy production, so the geothermal is very close to the nuclear. It's have a capacity factor close up to 0.7, 0.8. For example, for solar and for wind, we have a very low capacity factor. So if we have a 10 megawatts of geothermal, it's not equal to the 10 megawatts of the solar plant. So in Ukraine, what we have stakeholders, which stakeholders we recognizing in Ukraine. Right now, we have just one applications good developed as a recreation business, as a resorts or balneology, using for the swimming pools, for example. But there are a lot of applications we expect to be applied very soon. This is agro-business, this is greenhouses. This is local council, which can use this for heating and cooling applications. And also, this is high temperature area where we are expecting to have the electricity production and energy production and industries which can use this high temperature for different applications. I don't know, it's furniture, maybe paper, maybe salt producers, because the salt is quite interesting application now. We have lost the salt in the east, so we need the more salt. And another very unexpected question and very interesting challenge for the energy project in Ukraine. This is the resilience, because we have a war which is lasting 9.5 years, and we don't expect that it will be finished soon. So when we are thinking what energy type we want to build, we need to ask some questions. What damage is expected due to the rocket attacks, if any of this would be? For example, this night starts. We have 43 air missiles in Kiev, in central part, in the western part of Ukraine. And if some energy infrastructure was damaged this night, and we need to understand that it would be each year, each winter, we will have a lot of rocket attacks in Ukraine. And what the best option for resilience? We need to have many energy stations with maybe 10, 15, 20 megawatts capacity, but very resilient, and also it must be quickly repaired, and also not dependence for the fuel logistics, and also we don't need the fuel storages near these energy stations. And also, so can we hide our facilities for subsurface? For geothermal, the answer would be yes. So we have the energy source underground, and we have not so big surface facilities. And if any damages, we have big environmental impact for example, if fire appears. Okay, so let's go to the energy for the electricity prices. So if we start with the scoping study estimation, first of all, we trying to understand where is the market where we can sold our energy. We have the domestic market. We have a very regulated domestic energy market with the price cap. Currently, we have price cap about 18 euro cents per kilowatt hour. It's for peak generation, and the average price, daily price, would be 14. And also, we have the export option to the Europe, and Ukraine is a net exporter of electric energy before the war, and now as well, because in Feb of 2022, Ukraine was urgently signed the agreement with the European Union and synchronized electricity grids with the European Union, so we can get energy from Europe, and also we can sold the energy to the Europe. And the prices in Europe is quite different in different countries, but in average we took the estimation of 22 euro cents for per kilowatt hour. So if we see the economics for the small geothermal station, we have a long period of the exploration. And then we have the period of the deployment of this station. So payback periods would be from the start of the project would be very, very long. It's about 40 years. So for energy, it's a quite long time to have the quick payback of the investment. So that is why most of investment is not interesting for the geothermal project. So we need to think how to make these projects this period shorter. So this is the main problem we have for geothermal, for my opinion. Another point, we have big capexes, especially if we have not high temperature, not 150 or 200 degrees source. So if we're working with the binary cycles, with the binary systems, the good news that we have the trend to reducing of the capex cost during the time. So we can expect that the capexes will drop to the 3,000-4,000 dollars per kilowatts of installed capacity. So this is a good news. And another point we have, so if we talking about the exploration stage, so usually we have this exploration stage with exploration drilling, exploitation drilling, and feasibility study, site preparation, plan construction, and so on. So we have at least 8 years. To reduce this time, we need to use the existing geological information. That is why it's quite important to involve the petroleum companies in this business, because the petroleum companies has a huge data sets, huge geological knowledge. They know the sedimentary basins, they know the reservoir geology, they know the many properties about the petrophysics of the basin, about the fluid regime, about the heat flow, and so on. And that is why for pilot projects we can start not from here, but from here, where we have the less risk and more knowledges, and we can go directly to exploitation drilling stage, not for surface reconnaissance or exploration drilling, for example. So for UGV, we have 4 targets. We have the first target is the Transcarpathian, the second target would be Dnieper-Donetsk basin, is this part of, and in the future, we expect to have the targets in Donetsk basin and Crimea as well. So the typical cycle will last for life cycle assessment. It would be about 30 years. From these 30 years, we have 7 years for geological exploration, evaluation, plant design, construction, and at least 20 years for exploitation, max for 15 years. So 30 years is good estimation for the projects. And with this estimation, we are going to the real projects in Transcarpathia area. So Transcarpathia area is a very logical case study, because it's a Pannonian Basin, is the margin of Pannonian Basin. This is a map from Budapest colleagues from the University of Budapest published. So we here in the margin part of the Pannonian Basin with a good heat flow from starting from the 80 milliwatts per square meters up to 140 milliwatts per square meters, and we have a lot of measurements here. So the thermal gradient would be about from 30 up to 60 per kilometers, and we have a good distribution, so good coverage of data in this region. So that is why we are starting here for our pilot project. It would be very interesting case for Solotvino because it's very complex in sense of the geology, because we have a salt dome. We have this salt dome exposed on the surface, and here is abandoned salt mines, and we have some gas projects in this area. And we have some measurements with a good temperature in 3.5 kilometers with more than 100 degrees temperature. But there are a lot of interesting features for this basin. First of all, this is the Carpathian region with a potential seismicity hazards. The second one is the salt dome, is the salt tectonics, and some salt movement is possible during the geothermal project exploitation. And also there are very interesting temperature distribution, because the salt and the tuffs which is present in this region has a very specific thermal parameters. So we need to build a good model for this region. And then we also need to understand where the heat coming to this basin, because we have the two parts of this heat flow. One of this is conductive heat flow. We can check this heat flow, but the second one probably can go through the faults with the hydrothermal process. Because this is a Neogenian morass basin, and we have some volcanism in this area during the Neogene, and we have a lot of hydrothermal mineralization in this region, and also we have some abandoned volcano in Ukraine and also in Romania, close to this region in Ukraine. So it's quite interesting from the geological point of view. We have analyzed everything we have in this region from the thermal part, and we are starting from the regional assessment. So it's quite interesting to understand how this heat distributed regionally. And as we see, we don't see the like a flat anomalies. It's like bright spots, and we need to understand why in some parts we have such bright spots, what's the transport. So we need to understand the geothermal system from the source, transport, and the trap. It would be quite interesting. So we are going to the modeling. Because most of us come from the petroleum energy, so it's logical to try use the instruments from the petroleum. And we have started with the petromod modeling, with the burial history thermal modeling, to understand if it's possible to explain our observed heat flows by the burial history model. And our conclusions not. So the conductive heat flow, we have the temperature by this model, we receive it by the modeling, cannot explain us all features or spatial distribution of heat we have in this basin. So we need to go to the fluid flow regime. So we need to understand how the hydrogeology help us to transfer this heat in the basin. So it would be our next task. And also, it's quite interesting things we have found during the modeling, that the methodology of the temperature measurements is also very, very important, because we have many measurements from the well reports from the petroleum wells, and we have the measurements during the drilling or after the drilling, and such measurements usually is incorrect in sense of the heat flow analysis. Because for this example, I can show you we have these 2 points with a good methodology with validated temperature, with 120 degrees on this depth, and we have many measurements in the petroleum wells in this central part, and we have like a negative anomaly here because of we have the fluid regime impact on the temperature, and that is why this model is incorrect, and we cannot we cannot trust to this model, and we need to remeasure our temperature in these wells, and sometimes it's impossible because this is old wells we have. And another point, very important for the future geothermal projects, is geomechanics in reservoir, because not only induced seismicity is a problem we can identify in these projects. Another option, another assumptions usually we are using for the geothermal. So we have the temperature changes by the time. This is logical. So we are trying to make a model, for example, for 20 years, how the temperature will be changed within the reservoir, and how the injection well will impact this, and how the production rate will impact this. So this is accounted. So, but also, we are trying to understand what is the strain stress condition in the basin, and how this possible some induced seismicity impact would be. But we also need to understand this strain and stress will be changed with the temperature changes, because the elasticity parameters and the density parameters and the porosity and the permeability would be changed with the temperature changes, because the temperature derivatives are not zero for the most of the parameters, for the most of mechanic properties of the rocks we have. That is why most of these things, the porosity would be not constant, the permeability would be not constant. As a result, the reservoir shape would be not constant, because if we have a colder layer, we will have the less thickness for this layer, and we will have the less porosity and less permeability. And also, is it heat flow is a constant? Is it the heat flow is isotropic in the basin? Is that also big question? So we have a lot of challenges, a lot of work for the geomechanics, a lot of work for geophysics, for the reservoir engineering. So we have many possible ways where to improve our skills and knowledge in new energy. And finally, not finally, but the last slide for this modeling consideration, I wish to finalize with the different geothermal application, because this is a question of economy again, because we need to improve the attractivity of the geothermal. We need to find the added values for these projects to have the good consumption, not only the electricity energy and not only the heat energy. Probably some another applications can be joined for these projects. And this is like a conception. It's a lot when a conception we are thinking of. So we have the gas field in this area, and we wish to build the connected green energy project and combine the first geothermal. So we have a heat flow, we have a geothermal brines coming from the subsurface to the surface. And here is we have the geothermal energy facility, heating, and electricity. Okay. But because we have a salt dome here, so we have the high salinity, and this is the problem for geothermal, but it can be opportunity for the economics. So we can connect the salt extraction unit to this process, and probably it's possible to take the salt from this geothermal brine. And also we need to understand, is it possible to extract the critical raw materials, for example, lithium, for example, bromine, iodine, boron, or any other elements we have measured in the formation water, but probably some of them can be extracted. And the third options for geothermal, it's quite interesting, is a connection with CCS projects. This is a high risky projects. We need to have a very accurate model to make decision to work with the carbon injection with such formation. But this is possible to thinking about this. So if it's possible to put here another CO2 with cold water again, to mix the cold water with the CO2 and to make the formation pressure for the geothermal production. So this would be part of our future research. Okay, and finally, very, very important thing. We need to work with the education. We need to have the new professionals focused for the geothermal only. And there are some activities we are trying to do in this direction. The first of this we have formulated. We want to establish the PhD Transcarpathian Summer School to work with this conception I have shown in previous slide. So we want to start the like a modeling camp with some modeling tools, working with some universities like Heriot-Watt University, Delft University, Stavanger University, Arctic University of Tromsø, and other universities, and some Ukrainian universities to work like a business game. So we have short courses for geothermal and some practical training, and also like software working and simulational game to work with economic understanding, with the reservoir understanding, with the business understanding, and also with the startup opportunities, because it would be quite important to have not only big companies involved in geothermal, but many of small startups which can try several options of geothermal business and develop it. So we want to work with this application for PhD Summer School, and would be happy if any of you will join us in next years. And also, let me remind about the GeoHackathon. Do not forget to register. It's very, very interesting event. We have participated in the first GeoHackathon in 2021, and it was very, very useful for us. So thank you for your attention, and I am ready for your questions.
Very much, Ivan, for that pretty detailed, insightful presentation. And thanks for reminding the audience about the hackathon. I don't see questions in the chat yet. We might have a pretty shy audience. But before we move into that, there's a little poll that I'm going to pull up. You should see it on your screens. Essentially saying is, what do you think is more important for the geothermal energy development, right? Are we looking at technical innovation, or is it making the economics of projects worse? Because essentially, you talk to people in the industry, and there's a lot of, if it doesn't bring revenue, if you have no profits in it, people are reluctant to be in it, right? So we're seeing people are voting right now. I'm going to share the results shortly. We have 22 people that voted, so please let's increase that statistical density. All right, I'll give you another 30 seconds in the background. If you had any questions in terms of the presentation, put it in the chat box. We will address them to our speaker. All right, I guess I will end the poll right now, and I'll share the results with you. So essentially, we're thinking 83% say making the economics of projects work. 70% technical innovation. So in a sense, technical innovation, yeah, we have a lot of knowledge. We are working with the oil and gas. We're learning and sharing experiences, right? But in order to make economics of projects work, you need technical innovation, right? Because if you look at some of the economics of the geothermal projects, the drilling side of it eats up a lot of the budget. And the idea is like, how do we improve the technologies to lower the cost of these projects, right? So it's kind of an intertwined question. It wasn't really just a hard yes or a hard no. It was kind of a mix, but wanted to understand how the audience is thinking. I'm going to stop sharing. It looks like we might have a question from Mike, who typed only Ivan. I'm assuming he's typing right now his question. Give us a second here. All right. Well, until we get that question from Mike, I got a question. Okay, here it is. Interesting presentation, Ivan. Is like, apart from the war, what are your biggest challenges?
From the war.
No, he said apart from that. So he's aware that that is one of the biggest challenge. But what else are the challenges in terms of, I guess, the energy situation?
I guess the biggest challenges is the good combination of technology and economics. So my view, the main things we need to fit this balance between the energy supply and energy demand, because the geothermal cannot be profitable just only by electricity generation. So if you don't utilize heat production, you will be not profitable. So to have the good heat consumption, you need to understand the heat clients. So you need to drill your well very, very close to your customers. So this is a big challenge. So demand.
Okay, and he's asking also, what kind of technology would help you most in that?
What kind of technology?
It's more like planning, right? Not a technology.
It's like a intelligent design. Probably now we have one project submitted 1 week ago about the intelligent design, intelligent analysis of supply and demand in the basin and the regional scale. So this is quite interesting approach. I cannot talk about this right now, but probably would be.
What you're saying is understanding actually the challenge and planning ahead of how you're going to tackle it rather than start projects and then real time make the changes. We see some questions coming in from vote. great presentation. Thank you. So, what do you think about the main geological and technical risks for geothermal of DDB? Is this big depth cooler water or something else?
Yeah, it's big depths and the technological problem with well construction. Because if we have the wells 5 kilometers depths and old well, it would be very hard to repurpose such well to the closed loop, because to install the coaxial tubes it's technically very hard work. And drilling of the new well, the main stoppable factor for the drilling of new well is the price of the permissions, because by the new law of Ukraine, the new regulations, we need to pay for the meters of the geothermal projects. It's quite strange idea of our government, but for example, for 5 kilometers depth, we should pay a lot of money to have
But why
just only
though?
permission. Yeah.
But how does that work essentially, right? Because if geothermal represents a decarbonization plan and the heat is available, well, I'm not just speaking for the situation in Ukraine, but generally, wouldn't governments want to incentivize the development and not make you pay money per meter drilled?
Probably it was made to stimulate the show of geothermal. It's like a heat pump, because if you have a heat pump with 10 meters depth, so you can pay very small money. But
Yeah.
nobody think about the deep geothermal in this case.
Yeah, that makes sense. There is stars that ask you, do you consider like repurposing existing wells for geothermal projects or drilling new wells to actually develop geothermal?
Uh, I think would be better to drill new wells,
And
because
actually,
of
why is that? Why do you
because
think?
in Ukraine we have old wells with not the best quality. I guess this is main.
So it's a technical constraint, right? Well, integrity
Yeah.
and completion, etc., because that would cost a lot of money to remediate anyways. Um, we have Marco Kolovrat is saying, are there any feed-in tariffs and feed-in premiums in Ukraine for power production projects like in the EU?
Yes, we have a green tariffs for electricity production, but there are a lot of problems to managing these tariffs. But we have this like a premium tariffs for the green energy.
All right, so there is some sort of incentivizing.
Yeah.
Okay. Alexander is asking, wow, we have an active audience right now. Alexander is asking, what software do you use for modeling reservoir and geothermal process in the reservoir? What software you use to calculate heat losses in the well?
Uh, we are using the usual first option, the usual petroleum software like Eclipse or any analogs, which can support the temperature estimation during the modeling. So not isothermal model. Another option, the Leapfrog Energy. It was a leapfrog geothermal in the past, and also I can recommend you to think about the Delft University software. It's partially open access, so they very open to collaborate.
Yeah, I think they presented that recently at a conference. Oscar Calder is asking, first of all, great presentation, Ivan. Two questions for you. So we kind of touched on this a little bit. Do geothermal projects get state subsidy? And then what happens to the produced water after the heat extraction?
We have not the state subsidy right now. So this is also maybe stopping the geothermal developing. And what happens, the produced water after the heat extraction, we need to reinject it, because this is is not drinkable water. But we have one interesting project. Probably it would be, we are trying to check if it's possible to work with this. We are trying to make the project for water supply with about 30 degrees, 30, 40 degrees temperature, and trying to install the Rankine cycle turbine working on the CO2 to take the heat from this water and then use this water for the water supply. So we are checking this opportunity.
Okay, so you're looking into it. Thank you, Ivan. We have a all right. We questions come. All right, so great presentation from Yuri. What is the best approach to realize the project, independently or being in a partnership?
I have this on one of my slides. I think that there are 3 stages we have for the geothermal projects. So when we are starting the exploration of the region, we need to work with the grant money, probably in Ukrainian case, probably some donor money, and a little bit of own funding. And then we are, when the risk is reduced, so we can thinking about the credit investment and partnership investment. And the exploitation stage, you should working with your own investment and partnership investment.
Understood. Very concise. Thank you. There's a couple of questions coming from Mark Furman. He says, does water used in the geothermal cycle currently require a special permit for water extraction, even though it's reinjected?
Yes. Yes, there's
Okay.
another problem of Ukrainian regulations because we have to pay twice for the resource usage for the water first and for the heat second. And also we should pay for the reinjection of the formation water back to subsurface. This would be third payment.
A lot of payments. And
Yeah.
then that is not just there. Trust me, there's been a little bit of and maybe that is something we need to think of. The technical communities in the energy world is how much more can we, put the information out there, maybe educate the ones that make these decisions? Because once you start putting roadblocks and making it more difficult, you're prolonging the time it takes to actually develop a certain energy. So it's a good food for thought. His other question was, is there full legislation available for geothermal projects in general?
Uh, it's not like a single book for the geothermal yet, and this is also the good task for future to have the legislation, and legislation is changing very quickly. During the 1 year, we have many changes in the legislation, so you should be.
So we can make a change. We just
Yeah,
need to drive it. Someone needs to
yeah,
get the momentum. We have Yolimar that is asking, will the presentation be shared? Yes, Ivan has
yeah.
approved that. So the recording, and actually just to check now, Ivan, would you be okay if we share the PDF version of the slides or no?
I think yes. I will
Okay, we
prepare
can,
the PDF version to send
the
you.
shareable one. Yeah, feel free to change what you need to. We also get a question on the hackathon from Ankit. I will get a hold of you personally on that question for the Geo Hackathon. So I will address that. I'll send you a message. Essentially, you go to the website, there's certain categories you can pick on how you want to sign up. If you're a student, you click student. If you're a professional, you click on professional, etc. Right? So that's how you should do it. We don't have any more questions. I would like to close this to ask you even one more question. And I find it very inspiring, this PhD summer school. I think that's an amazing effort because, as you mentioned earlier, education is going to be the key for the coming years. I mean, now it's 2023. We have our own thoughts and our own actions, but what's going to happen in the next 5 to 10 years, whether that is locally in Europe or in the world, is going to highly depend on the education of the people in the industry, right? So first of all, I wanted to congratulate you for that. And then you said join us? Is it very easy to join this? How does the process work for that? I mean,
we have in the stage of reworking of our application, because the first attempt was rejected with a good mark, but with some comments from the raw materials fund. It's quite interesting because it's not direct the geothermal, but this is the critical raw materials fund. And SPE Central Europe section is a part of this application already. And we planning to resend the application in January of next year. So we can work with this application with the idea for next 2 months, and then create the good application to win this this grant in next year.
okay, thank you. There will be more questions, but there will be a time to ask you those. Diego made a comment on a great session. He's the representative of SPE Spain, so thank you, Diego. There is no more questions in the chat box. I would like to thank you directly, Ivan, for being available and taking the time to do this. I would like to tell the whole audience that we are coming with a special geothermal talk number 8 next month. It will be an interesting topic on drilling in geothermal wells, so keep an eye out. We're going to start promoting it next week. We want to keep building this community of the geothermal world and keep driving these sessions. So thank you for all the support. We will send you the recording and the updated slides by the end of the, not by the end of the week, but next week most probably. And thank you, everyone. Have a great day.
Thank you all. Bye.
Thank
Have
you.
a nice day.